Hello, everyone. Welcome, and thank you so much for joining me this afternoon for our workshop. My name is Molly Webb, and I am a GIS and data developer with the data services team at the University Libraries. I'm also the coordinator of the GIS certificate at University College. I'm here today to share with you some tips, tools, considerations when you are working on visualizing your data. I stopped short of calling this presentation best practices because sometimes data visualization is subjective and I have very much of my own point of view in this presentation, but there are some generally accepted and common sense things in here for us to talk about. Also, while the use and display of three-dimensional or 3D data in graphics are becoming more accessible to the average user, this presentation is going to focus on two-dimensional visualization. So let's begin by just getting to know some of the data resources available to you as part of the WashU community. Data Services is part of the University Libraries, offering data-related expertise services to the WashU community across both campuses. Our target areas include the management, sharing, curation, wrangling, literacy, and visualization of all kinds of data, as well as support for GIS or geographic information systems. I'd like to introduce you to the Data Services team. We're led by Jennifer Moore, and I'm joined by my colleague, Sarah Swans, who's our digital humanities librarian and data curator, and my colleague, Bill Winston, who is our GIS and 3D data analyst. Our contact information is here, and you can always reach us at the university website as well. If you are on the medical campus, I definitely recommend getting to know our colleagues on the research computing and data management and sharing teams at Becker Medical Library. They offer a set of services and expertise tailored for the School of Medicine's unique needs. Okay. So we're going to start with some things to keep in mind when it comes to visualizing your data. And of course, the first thing that we need to think about, of course, is the data. So data visualization is communicating with visual models of our data to make it consumable. Ideally, you want to be able to tell the same story to both experts and non-experts, but the specifics of how you tell it may vary depending on your audience. Either way, it's all about that data. So keep in mind, visualizing your data doesn't have to wait until the end of the project. Creating visualizations at different stages of the research process can provide insights, help you explore the variability of your data, and to discover relationships. When communicating your findings, more isn't necessarily more. So it's important to choose visualizations that are key to the story that you want to tell. Now, creating data visualizations typically involves some kind of preparations on your data. You may have gathered and prepared your data for analysis, but the data may need to be reformatted or enhanced in order to have it visualized properly. And this is commonly called data cleaning, scrubbing, or normalizing. If you joined me for the workshop on Tuesday, you heard all about it. The output is typically a new table or multiple tables that will be reformatted to fit whatever data visualization you're trying to do. Keep in mind that you may need to add additional information to normalize your existing data so it can easily compared across categories. And what I mean by that is something like the normalization of COVID cases per 100,000 people to account for differences in county populations for the areas being compared. So the map on the left here, if you look at total counts, you may think that certain areas are actually much worse than they really are, since logic tells us that areas with higher populations are going to have a higher number of cases. By normalizing the data using a rate, like the map on the right, it makes sense the comparison across different areas makes a little bit more sense, and our at a glance look at this map might give us a better idea as to what is actually happening in different areas. So another consideration when you're creating your data viz is the planned audience, or at least kind of have an idea of the audience. It's important to consider what you want to focus on as well as what the audience might want to see. Are they administrators of your organization? If your audience is a group of decision makers or even funders, be sure to tailor the information to their requirements or items that they might feel relevant to their evaluation. The information presented should be compatible with the specific expertise of the audience. If you are presenting to a group of peers, say at a conference or something, you can probably take more liberties with the use of jargon and acronyms, but take care to make definitions accessible to those who may not be as steeped in the field, like maybe students that are just starting out. If you're creating visualizations for the general community, you may want to keep things as simple as possible and use bold yet cohesive and meaningful colors to highlight the key takeaways. Bottom line is that you never want your audience to have to work too hard to interpret the meaning of your visualization. Your audience may also determine which platform or medium you choose. And it can also be a really important factor when you set out to visualize your data. So are you presenting in person? Make sure that the viz is of sufficient size and contrast to account for things like really bright lights in your presentation room or a weak projector. Is your audience particularly tech savvy? Then you may want to consider making your visualization interactive or at least electronically available. But then again, on the flip side, you may have some audiences that might appreciate a printed handout instead of clicking on a link. So with this in mind, you also may need to consider making different versions of your visualization tailored to these particular platforms and audiences. Also related to the medium, if you're creating visualizations for publication, be sure to check the specifications of the publisher, preferably before you start creating at least your final versions. So here I have some excerpts from the formatting guide for the journal Nature, as well as their standalone final artwork guide. So be sure to locate those, read them, understand them ahead of time, so you aren't scrambling at the last minute if possible. Publications may also have guidelines in terms of whether or not figures should be in color or black and white. So make sure you keep that in mind. So speaking of color, color is going to be the first in our list of basic visualization principles. Color can be one of the most important ways of separating out our data points into groups or data series, indicating differences. And it's important, however, that color is used to simplify our data, not to confuse it. So use color to signify meaning when it's appropriate, but don't use it when it doesn't have meaning. And what I mean by that is something like this. If we take a look at the bar graph on the top left, the data is already grouped or separated by categories into the bars. So making the bars different colors doesn't really help to differentiate, and it may cause the audience to search for meaning in the colors when there really is none. So if color doesn't mean something, just make it consistent. Same with the map of Missouri counties here in the middle. So the top map here shows each county with a different color, which is unnecessary unless those colors actually do have meaning. If the colors don't mean anything, it's best to use a neutral or consistent color. And then on our pie graph here on the right-hand side, the donut chart on the upper right shows the category with the largest proportion of the whole in a light color. Now, our eyes tend to fill in areas and patterns on their own. So generally, you would want to use a darker color as the main color, and then the lighter color or alternate color to fill in the rest of that space. When color does matter in your visualization, it's important that you choose your colors wisely. So there's lots of considerations when choosing colors, but here's just a couple of suggestions when it comes to the nature of your data. So these color palettes are from Color Brewer, which is a great website to help you with your color choices. They're geared towards cartography, but really the color palettes can work in lots of different scenarios. There's also many, many other color palette generators out there. So a quick Google could bring you probably a lot of options or inspiration. All right, so at the top, we have our diverging color scheme. And diverging color schemes give us emphasis to both the low and the high extremes of your data, but it also makes the middle value really easy to recognize. So it's best for situations where there's a mid-range critical value shown in the data, like the mean or the median or maybe 0. This scheme shows us which data points are above or below the important value with different hues for easier interpretation. If the nature of your data is sequential, matters from lowest to highest, then consider using something like this sequential color ramp here, where there's one general hue and then lighter versions represent lower values, and then the ramp progresses towards higher values shown in the darker versions of this color. Now, when you don't want color to represent any particular magnitude, but differences between categories, then consider a qualitative color scheme where different hues are used to create visual separation. Now, related to color is contrast, or the difference between the colors of the color elements in your visualization. So the platform, again, that you use is going to be a big determinant for how much contrast you should use with colors. Again, I just want to bring up the point of having like bright lights in your presentation room. Keep in mind that your colors do need to be different enough to be interpreted. Contrast can also help any viewers that may experience differentiations of color blindness as well as other visual accessibility needs. So we want to make sure that everybody can properly gain the insights that you're trying to convey, even though they might not see the exact differences in the actual colors that you've used. So for example, the graphics on the top row of this slide, you may be able to see them, you may not. They are there, but they're in a color that is so similar to the background color, they're probably appearing almost not at all or showing like they're invisible. A better bet would be to use a highly contrasting color so that the graphics stand out against the background. And if you're tied to a particular color palette, maybe due to some kind of branding guidelines or something like that, you could try including an outline or a stroke around the graphics to distinguish them from the background color. In terms of text in your visualizations, the same principles apply. The gray text in the top bar here would probably be almost invisible on certain screens or platforms. So when selecting the color for the text, it's best to keep it simple with like a dark gray or a black, unless you want the color of the text to convey some kind of meaning. Also, true black on a white background can be a little harsh on the eyes. So my preference is to go with a very dark gray. Now, keep in mind, if you're going to use dark gray for text for a graphic, you also might want to make sure that the other lines and symbols, such as your axes lines and tick marks that would normally be black by default, get changed to the same dark gray as well. So this makes for a polished and professional kind of cohesive look to all your visualizations. Color and contrast can often go hand in hand. Too many colors on a visualization can overwhelm the viewer, and it's likely that there may not be enough contrast for them to interpret the differences between the categories. The map on the left represents 10 different classes of data, which is probably too many. It would be tough for the viewer to distinguish between some of these colors, especially in the middle range of our palette here. So as a rule of thumb, it's preferable to keep the colors on your viz to about 5 or less. This is, of course, unless there's some extenuating circumstances, like you must show more than 5 categories. But 5 is typically the maximum number that the human brain can really distinguish comfortably. And remember, it's all about making sure that the audience does not have to work too hard to get the meaning of your viz. All right, so the next principle we're going to look at is balance. When we're creating our visualizations, especially when we're grouping to get them together, we want to do our best to keep the presentation space in balance. This doesn't necessarily mean that the two sides mirror each other, but it means that the elements are distributed equally across the space. This is especially the case when working with media where you plan to present multiple pieces of information and visualizations like a poster or a dashboard. When it comes to including multiple vises in your work, again, more isn't necessarily more. It's important to choose the visualizations that are key to the story that you want to tell. So typically when we think of the balance, we think about maybe 3 different frameworks to work within. Symmetrical, where each side or section mirrors each other, like right to left or top to bottom. This is a pretty classic look for groups of data viz. You could go with the asymmetrical presentation, which has unique elements on all the sides, but they all carry a similar visual weight. This type of layout is considered to be a little bit more relaxed, but it can still be balanced. And then you could go for something like this radial presentation, which focuses on a single central element and then fills in the rest of the space around it with other types of viz. So this viz is going to bring the eye to that central focal point that you want to get across. While we're on the concept of balance, a little side note here to make sure that you explore and take advantage of any arrangement or alignment tools or guides within the application that you're using to create your visualization. This includes tools that allow you to align elements to each other or evenly distribute them across a space. A quick Google is probably going to tell you if your preferred application has these tools available. So it's not only going to help you with your balance, but also creates that overall cohesive, polished, and professional look. Next up, we want to talk about legibility. So it basically means, can your viewer read or see the information clearly in the space? Can the words and letters be distinguished from one another? Can the graphics be interpreted? Can the objects and the images be identified? So an example of that here is any images or logos you might bring into your viz. So if you're designing something for a larger format, like a poster, or something that's going to be displayed on a really big screen, be sure to obtain high resolution images or logo files to avoid pixelation when the image is enlarged. So the logo on the bottom is much more legible for a presentation of this size. You also might want to avoid small text or big blocks of small text in your presentation space, especially if it's meant to be viewed from afar. An example of this we're looking at right now, maybe you're at a poster session or at a conference or at a community meeting. It's going to be really hard to read all of this text kind of at a glance. So what I would recommend in this case is a very brief description with maybe a handout or a separate website or link in case the reader wants to know more about the data or the analysis that was performed. Also, in terms of legibility, it may be really tempting to kind of spruce up your visualizations with a cool font, but try to keep the fonts as classic and simple as possible. So on the left here, we're using the font Comic Sans, which kind of looks casual, but it's not really a favorite among most designers and typographers. There are definitely more professional options, even if you are going for a unique look. The font in the middle has serifs, which are the small strokes at the end of the letters. And depending on the situation, serifs can make it a little difficult to distinguish the characters from each other. Other decorations, such as drop shadows, can also make the characters kind of run together. So while there's no one size fits all font here, I recommend going with clean sans serif fonts, kind of like Arial or any of the fonts in that similar family. While we're on the topic of fonts, avoid using vertical orientation for characters like this y-axis label here in the graphic on the left. When you're trying to fit a piece of text into a small vertical area, rotate the characters so that the bottom of the characters are aligned with the object that they're describing, like the graphic on the right here. Okay, and then finally, transparency. So while we're trying to tell the story that we want to with our data, it's important that the visualization does not misrepresent your data or your analysis. So don't use tricks like uneven intervals between the numbers or classes, using inaccurate or inconsistent scales when doing comparisons, or fudging with the starting point of an axis to exaggerate the values. So here's a couple examples of that. So on the left, this bar chart is probably intending to highlight the decrease in the percent increase over time in fuel prices here, but none of the scales make sense here. The bars aren't proportional to any of the values shown. On the right, there's several issues that we can see here, probably not malicious, but they certainly are deceiving. So this is the average respondent rank for the method of transportation. And if you read a little bit further, you'll see 1 is the most, being the biggest priority, and 6 should be the least. But when presenting this graphic, 1 is at the bottom and 6 is at the top, like we would normally see them. And so it really makes it tough to see, okay, well, what is actually the priority here? Also, like I mentioned before, we're using, this graphic uses different colors to differentiate between the categories, which isn't really necessary considering that they're labeled down here across the x-axis. And then also kind of cluttering up the viz is this legend, which corresponds to the colors. But again, since the bars are labeled straight away underneath the x-axis, the legend is completely unnecessary and repetitive. All right, so to wrap up transparency, if you didn't collect the data yourself, you must reference the data source. And if the data is publicly available, be sure to apply a link or provide a link. Descriptions of the data should be clear about the methodology used to prepare and analyze the data, the sources and the limitations of the data. So it's important for the viewer to understand that this is your curated visualization and probably doesn't represent everything there is to know about the data. So each of the principles that I just talked about could probably be studied and debated and discussed at length. My point in including these items is just to get you to make conscious and deliberate decisions when it comes to the preparation, presentation of your data. Okay, so next we'll go on to some types and tips. So there are many, many, many types of data visualizations out there, and the list grows daily. It's easy to get really overwhelmed with all the options, and we are frankly bombarded with data visualizations every day. So my recommendation, as always, is just to keep it really simple, focus on the main objective or the results of your research that you're trying to show when you're making these kinds of choices. For guidance, sometimes I like to start with this chart chooser flowchart, which was created by Dr. Andrew Abella. It starts with the simple question, what would you like to show? Do you want to show a trend over time and have many time periods worth of data? Is the data non-cyclical? Then perhaps choose a line chart. Do you want to show relationships between variables? Do you have 2 variables? Do you have 3 variables? So either a scatter plot or maybe a bubble chart that uses both the Y and X axis as well as the size of the symbol to convey meaning. So take a look at this. I kind of like to explore it if I'm kind of stuck into how I want to present something. It can be a really good tool to at least get you started. Charts and graphs, they're often very similar and the words are really used interchangeably sometimes. They both rely on an established pattern or a theme to convey information. Some experts consider the difference between the two is that the graphs rely on axes like an X or a Y axis or both to make sense of the information. And so this means that at least in graphs, at least one of the data points is going to be numeric. Whether you're creating a chart or a graph, like I mentioned before, avoid the impulse to add more information or graphics or decorations. Some experts even go as far as to say, don't use tick marks. They just add extra junk to your charts. But the important thing to remember here is consistency. Make sure that the spacing along your intervals, along your axes are consistent. If you're using proportional symbols, make sure that the symbol size is in fact proportional to the value that it's representing. If you have data that would require different scales on the same line or bar graph, like this example here has 2 axes, consider splitting them into 2 graphs instead of trying to combine different scales on the same graph. Now, pie charts also have kind of a mixed reception among some data scientists and design experts. If you choose to use a pie chart, make sure that it's representing portions of a whole and that the percentages add up to 100%. If you're trying to show a percent change, like the percent increase in growth, then probably a bar chart would be a more appropriate choice there. I like to recommend to show the portions in order from largest to smallest, starting at kind of the 12 o'clock position here and working your way around clockwise. Also, don't include too many slivers or pieces of the pie. If your viz gets to the point where you have to have more than 1 or 2 callouts showing different sections that can't be labeled directly on the shape, then you may want to consider combining categories into an other section or separating out the data points into multiple pie charts. So a couple of examples here. First, on the left, if you're going to be using a pie chart, make sure that all the slices actually match the value. This yellow portion here certainly is not 72% of the pie. It's probably more like 90 or 85. On the right, we have a situation with multiple callouts for the different pieces. And then again, kind of like I mentioned before, we've got a really unnecessary legend here, especially since all of these pieces are labeled here at the top. And then we've got this pie chart is a 3D pie chart. So to that, I just have to ask why. Like, why does this pie chart need to be 3D? I would say it absolutely does not. All right, so while it's not set in stone, if you just have a few data points to show over time, then consider using a bar graph, kind of like this 15-month bar graph here on the left. If you have many, many data points over a long period of time, then consider using a line graph. Line graphs can usually show trends a little bit more clearly. Here's a notable example of a graphic that doesn't necessarily follow this guideline, but it does work pretty well to convey the data because all the data is at the same scale. So we have the bars that show the number of daily cases and then the line which shows the 7-day moving average. Now, speaking of scale, here's an example where 2 data points for the bars are technically at the same scale, but the numbers vary so much that it's really kind of hard to see the different data points. So in this bar graph here, we have the number of daily cases here, And then we have the number of daily deaths, which is shown in the purple bars, but the numbers vary so much that you really can barely see the purple bars down at the bottom of the bar chart. So in this case, you may consider doing a separate graph for the dates so you can adjust this, or excuse me, for the deaths, so you could change the scale and make it a little bit more legible there. Keeping on with the bar graph theme here, it is important to consider the order in which you place the bars based on what you're trying to show. So the graphic on the left shows the bars in alphabetical order by category, which isn't necessarily wrong, but if the point of your graph is to show like which data point is highest or lowest, then consider reordering the bars so that it's really easy to see which categories come out on top. Now, on the flip side from there would be any data where there's a date or some kind of order of the bars that would dictate what the order of the data points need to be. So in this case, if we have data by quarter, so if we ordered the bars in terms of highest to lowest, then our numbering is all off. So in this case, we would want to adhere to the time-based ordering of our bars. So then you can see the changes in between the colors. All right, so since I'm a GIS person, I definitely am going to give a plug for using maps to show your data, especially if you have information about place or geography, zip code, county, things like that. So same rules apply. We can still use different color schemes. So the map on the left is showing our sequential color ramp that we talked about before, showing values from low to high. The map on the right is showing our diverging color ramp that shows kind of the little change value in the middle and then goes up or down based on the diversion from those middle values. So maps can be pretty powerful in terms of visualizing data that is tied to a place on the earth. For example, I have this table here, which is ages, or excuse me, it's by zip code, and it gives us the number of people age 65 or older. When we're looking at this table, it's kind of hard to see like what is happening here with the data. But if we transfer that data to a map, then it's really easy to see the different areas of the groups, the higher values of older individuals. And this could even help you with prescriptive actions, like targeting certain services for certain areas and things like that. Okay. And so again, depending on the platform or the goal of your viz, you may want to consider creating an interactive graphic. So an interactive graphic or an interactive map where users can click on various elements, get pop-ups to show certain information. This is great because it allows you to have that overall picture of the data, but then if a user wants to dig deeper and actually click into some of the elements, you can provide additional information in that regard. So I definitely recommend to check out some of those options if this would be appropriate maybe for your viz. And we'll mention a couple of those tools in the next section. So as I mentioned, there's lots of different considerations to choose when we're talking about our vizzes, and these are just some of my preferences and tips that I've come across in my time working with data, especially here at WashU. There's lots and lots of different considerations and types of vizzes that I didn't cover here. But at the end of these slides, which I sent you the link, I'll make sure I send that out again. There's a resource list that covers pretty much everything I mentioned if you'd like to explore it further. So bottom line here is to keep it simple, focus on the data. And I like this quote from Tufte. Data graphics should draw the viewer's attention to the sense and substance of the data, not to something else. So not like graphics or cute pictures of kittens or whatever. We want to be talking about the substance of our data and the message that we're trying to get across. So, when you're working with data, just the same as doing your analysis, there's lots and lots of different tools that you have available to you. Too many for me to go into anything in great detail here. But what I wanted to do is just bring up a handful of tools that I like to use and that we have resources and support for you here at WashU. So when using any tool, just my recommendation is that once you have the basic graphic made, then try to move on beyond the default settings. Even if it's just kind of changing up some colors and fonts, that can make a big difference. Be sure to check the labels and titles and make sure that they are in the most concise language possible. So some tools for static vizzes, which you're probably already familiar with. Of course, there's Microsoft Excel, which also includes things like Apple Numbers and Google Sheets. They all have pretty standard visualizations built right in. You can get them up in just a couple of clicks. This would be a situation where I would encourage you to move beyond the defaults. And in the resource list, I actually recorded a couple of tool demos for you since I knew we probably weren't going to have enough time to get through them in this workshop here. I have an Excel Beyond the Defaults demo that I provided for you here in the slides. In terms of static, I also really like to use R with RStudio Desktop. Adobe Illustrator has really robust capabilities for making data vizzes, and then there's lots of different Python libraries too. There's tons of other tools again, but these I just wanted to highlight because we can specifically support these here for you at WashU. But, no matter what you're using, if you need help, I'm going to try to help you, even if I'm not super familiar with the tool. In terms of mapping, like in desktop GIS applications, there's ArcMap and ArcGIS Pro, which have really robust cartographic capabilities for creating reports for things like, creating maps for things like reports and publications. There's also an open source GIS called QGIS, which has nice cartographic options as well. If you're interested in creating some of those interactive vizzes that I talked about, there's Tableau. Tableau comes with a Tableau desktop or Tableau Public, which is freely available to download and use. ArcGIS Online is another product we support here at WashU. Through the library, we have a subscription to Social Explorer, which has great cartographic outputs and like story mapping type capabilities. I should also mention story maps are part of ArcGIS Online as well. And then Microsoft Power BI, which is kind of like a similar application to Tableau. If you are interested in Tableau, I've provided a link here to the Washington University Tableau users group. They have a fairly active Teams channel as well as periodic meetings. I think they're about quarterly right now. So there are some folks on campus that are really, really great with Tableau. So if you have any questions, feel free to check out this website here and see how you can get some help using Tableau or maybe just learning more about it. Okay, so in our last few minutes here, what I wanted to do is play a little game, a little data viz critique. So what I'm going to do is I'm going to show a data viz that I found, and I'd like you to take a couple minutes and see if there are some issues that you have with the viz, and then go ahead and put them in the chat, and we'll see what we come up with. All right. So here is our first one. So go ahead and take a couple minutes, look at that, and then when you have some ideas, throw them up in the chat with some places for improvement, let's say. Okay, so contrast. Yeah, I would definitely say that the background image doesn't allow for a super great differentiation between the background image and the graphic. Font size, background image, absolutely. The font is really kind of small, especially if you're looking at it from far away. All right, so I will just kind of point out some of the things that really, oh, yes, great. Yeah, absolutely. So interval of each year, absolutely. That was a big one for me. Generally, overall, it is unclear. Yes, I would say that as well. It's really hard to grasp what they're trying to say here, especially with like the labels being in red, which blend right into that background image. So exactly, I agree with everything that was put in the chat. The background image really was not great for me. It's unnecessary. It clutters up the overall message. And then the inconsistent x-axis values were really big for me. We've got a 1 year gap here. Then we've got 4, 3, 3, 3, 3, 3, but then 2. So perhaps for something like this, you know, if you don't have consistent data points, then what I would do is probably leave some sections blank, just so it's not, you're not trying to convey that this is a overall trend. If you, something like this, maybe you could even do a bar graph and have some of the bars like blank and explain to your reader, oh, there's no data for this section. No data is also data, it's fine. But you just have to be clear about not having that data. All right, thank you so much for those. Let's go on to the next one. Okay, go ahead and take a minute. Okay, so comment, too much info on one chart. Yes, I would definitely say that. Percent not proportional to the size. Bingo, that's what I was thinking as well. So really, those two comments kind of hit the nail on the head. Font type, scale, icon usage, exactly. That's exactly what I was thinking too. So for this one, obviously the big one, the pie pieces are not proportional to their values. So that's a big one. Just don't do that. The icons for me add unnecessary clutter, and they're really not helping to convey the story very much, especially since we are, since we're just listing or labeling out those sectors right on the pieces of the pile or the pieces of the pie. Another thing for me, yes, exactly. Thanks for grabbing that last one. You have to flip your head to read it. So the text rotation, that was also big for me. And this can be kind of tricky when you're doing a pie chart or a donut chart. It's tricky to know how to handle that. So, you know, these labels and these labels are probably fine. But when you get over here to this development project section, you do have to really kind of like crane your neck to see or to read that one. And even right here, the hydrocarbon, same thing. So what I would recommend here is instead of rotating the labels, maybe just keep all of the labels, you know, just top up, because, and, you know, if they don't fit on the pieces of the pie, you know, maybe have the labels be outside the pie or something like that. But yeah, you hit all of the high points that I also found with this viz. So very nice on that one. All right, let's go ahead and look at our final one. And of course, it's a map. Okay, so first comment coming through, using different colors may help differentiate the numbers better. Absolutely, that's the big one for me. The other things that I found with this map are a little bit nitpicky, so it's okay if they don't. Yeah, Northeast Corridor is always difficult to read. Absolutely, yeah, it's hard to kind of make that work in a map of the entire United States. Hawaii is missing. Bingo. You got that one. That was one of my items too. So let me tell you what really jumped out at me with this viz here. So I wrote, why not indicate values with color, either alone, or you could also still include the labels if you want. Some users may enjoy seeing the exact numbers, which is fine, but it's a real missed opportunity here to convey the meaning of your data at a glance using color. So definitely in this situation, I would personally, I would probably only use color, but labels are fine too. I'm not even certain if the states need to be labeled at this point. That might just be creating additional clutter, but other folks might have some different opinions on that. Obviously, Hawaii missing, that was a big one for me. If you're going to completely omit something, again, if you have no data for it, then just say no data for Hawaii, no big deal. Just put it right out there. And then the other thing that I noticed, and this is kind of a small thing, and it might be a little bit nitpicky, but the scale provided was for 900 miles, which is kind of an odd distance. I don't really have like a great frame of reference for what 900 miles is. Typically, whenever I'm making a map, I like to make the scale, the graphic scale, for a nice round number. So in this case, I might do 1,000 miles, or I might do 500 miles. I mean, it might not make a huge difference to the reader anyway, because once you get past a certain number of miles, it's hard to really understand how much distance we're talking about here. But in this case, I would say maybe take it down to 500 miles and take up a little bit less space with your scale. All right. Well, thank you for playing that little activity with me. I appreciate it. I had a really good time looking for visualizations to show in this activity. So I do just want to call out, there is a Reddit thread called Data is Ugly, which always has really great examples that people find around the internet or on television or whatever. And they post those. And of course, there's lively conversations happening around each of them because everybody has different opinions about data viz sometimes. Okay, so the last few slides here, again, I mentioned I recorded some tool demos for you. If you would like to take a look at those, they're just YouTube videos that I've linked to here. And then I've included a lot of different links specific to WashU services that you might like to take advantage of, and different tutorials that my team and other teams have put out there, as well as some public resources and things that I specifically mentioned in the presentation today. Thank you so much. I really appreciate you joining me this afternoon. Thank you.